So y plus 4 equals x minus 2 squared, which equals x squared minus 4x plus 4. Canceling 4 from both sides means that y equals x squared minus 4x. And the other equation gives us that x equals y squared minus 4x. And so the next thing to notice is this thing of like x does not equal y should be a big red flag. This should scream to you, oh, there's definitely a root. There's definitely like multiple roots probably. There's definitely like probably like multiple pairs of solutions x, y, where x equals y. And so let's find them. So if x equals y, then x equals x squared minus 4x, which means that x squared minus 5x equals 0, which means that x equals 0 or 5. And in fact, yeah, x minus y equals 0, 0, or 5, 5, both work. 0, 0 makes both sides of each equation 4, and 5, 5 makes like all values in the all like of the equations equal to 9. Okay. Now that we have that, we know two roots now, and based on that, we can kind of confidently do. We can now kind of confidently do this. We can write x equal y squared minus 4y, which equals y, which equals y times y minus 4, which equals x squared minus 4x times x squared minus 4x minus 4. Yeah, there we go. Okay, so we can fairly confidently do this. And now we can start. And so we're guaranteed, since we know that like the solution xy is 0, 0 and 5, 5 both work, we know that x equals 0 and x equals 5 should be roots of this equation. So firstly, we can get rid of x equals 0. Oh yeah, and by the way, if we have a value of x, it uniquely determines y, and if we have a value of y, it uniquely determines x. So if you know x, it gives you y, and if you know y, it gives you x. Yeah, so if we can get rid of x equals 0 by dividing through by x. So 1 equals x minus 4 times x squared minus 4x minus 4. Now we can expand and cancel. So this is x cubed minus x squared plus 12x plus 16. And then we're going to cancel this down. But we also know that 5 is a root. So we can factor out an x minus 5. So yeah, we can factor out a factor of 5, and then we can divide through by x minus 5, because like if x equals 5, then that forces y to be 5, and we have like the degenerate x equals y solution. And so that means that 0 equals x squared minus 3x minus 3. And so yeah, those are the that represents the two values of x, which like when you apply like x squared minus 4x twice, gets you back to, like if we write f of x to be x squared minus 4x, we're basically finding we're trying to find a pair x and y such that f of x equals y and f of y equals x. But we want it to be like x to y and y to x. It's not just like x to itself twice. And yeah, so we've gotten rid of the two cases where it's just x back to itself. That was like the x equals 0 and x equals 5 case. And so it should be unsurprising actually that we're left with x squared minus 3x minus 3, because that will represent like the two solutions to x squared minus 3x minus 3 will represent the value of x and the value of y. And both of them will, if it has roots r1 and r2, based on the algebra we've just done, we know that f of r1 equals r1 and f of r2 equals r2. So both of them under two applications send themselves back to each other. And these are the only, r1 and r2 are the only values which have this property, which means that r1 and r2 should be the values we want. And yeah, so x squared plus, so yeah, x equals r1, y equals r2. So we're looking for r1 squared plus r2 squared, which we can just get with Vieta's, which will equal 15. Yeah, the main idea here was to just plug in x squared, y equals x squared minus 4x into the equation x equals y squared minus 4y, cancel out like the fixed points. F of 0 equals 0 and f of 5 equals 5 are fixed points, which is a pretty important concept which will show up a lot, like not necessarily in competition math, but in like linear algebra, complex analysis, just like a lot of math uses this idea of fixed points.